Hello everyone, this is Miss Salter, and this video is on calorimetry and heat transfer problems. Okay, so what we're starting off with is a coffee cup calorimeter. So we have a coffee cup, and this coffee cup has a lid on it, and it has a thermometer. And the cup. Inside the cup, we have a sample of water. And basically what we do is we use this system here to figure out the change in a reaction. So in these examples, we're going to be doing a transfer of heat, because heat is a transfer of energy, from a little piece of metal. Okay, this metal is heated up, and then we put it inside our calorimeter, and we monitor the change in temperature of the water and the metal. So usually what we're going to do here, we have what we call a system. That system is the metal plus the water. Okay, now the metal has a mass. So we have a mass of the metal, and we have a temperature of the metal. So this is the mass, and this is the temperature. And then we have the water, and we have a mass of the water, and we have a temperature of the water. Now with the ones we're doing, we're going to assume that our metal is hotter than our water. So we're going to assume that the temperature of the metal is greater than the temperature of the water. So that means that the heat is going to transfer. We're going to have a heat transfer from the metal into the water. Now, that means that the temperature of the metal is going to decrease, and the temperature of the water is going to increase, and we're going to end up with a temperature somewhere in the middle. So therefore, the temperature of our metal is less than the temperature of our final, which is less than the temperature of our water. So the metal is hotter, it's going to transfer energy to the water. The water is cooler, it's going to gain energy from the metal. And we're going to end up with a temperature in the middle. Okay, so just move this up a little bit. So now, since our system is the metal and the water, we have what's called a closed system. So now, in this instance, our energy of the whole system equals 0. So here our metal is going to lose energy. So it's going to end up with a Q value of the metal, which is negative. The water is going to gain energy. So that means the Q value of our water is going to be positive. So since this is a closed system, and the energy of the whole system equals 0, and we know that the metal plus the water equals the system, then we know that the Q value of M plus the Q value of the water equals 0. And that's how we prove that the energy in the metal is equal to the negative energy value of the water. The metal is losing energy, the water is gaining energy. Oh, I see. Yep. So here we have, now it might be a little bit confusing here how I have this mentioned. Here, our water is gaining energy, so it's absorbing, and that means we have a negative value. It gains, it's absorbing, the energy is a negative value as far as our equation is concerned. All right, so now we're going to use this to figure out an example. So, as we learned before, our equation we're working with here is Q equals MC change in T. And the change in temperature equals the TF minus the TI. Final minus initial. Now, this C value here is different. This C value right here is different for different substances. So we can have, we can identify what metal we are working with depending on the C value that we can calculate from our problem. All right, example problem. So if we have an example problem that says, so our example problem says we have a 50-gram piece of metal with an initial temperature of 100 degrees Celsius is added to 100 grams of water with an initial temperature of 20 degrees Celsius. The final temperature is 23.5 degrees Celsius. Calculate the specific heat of the metal. And the C for water is 4.184. Okay, we need a diagram. So, we have a little coffee calorimeter here. And we are going to put some water in there. Okay, so the water, the mass equals 100 grams. the initial temperature of the water equals 20 degrees 20 degrees Celsius. And we have a little block of metal. And our metal is hot. So our metal is 50 grams. And its initial temperature is 100 degrees Celsius. And then our final temperature, TF, is once this goes in here, it gets to an equilibrium. Our final temperature is 23.5 degrees centigrade. And we know that our C value for water is 4.184 joules per gram Celsius. Okay, we are trying to find out what the metal is. So we are looking then for, what is the metal? And we do this by finding the specific heat. Okay, so how are we going to do this? Okay, so we have two things. First, we are going to use our Q equals MC change in T. Now we have a lot of information here that we're going to be working with. And what we're going to do is we're going to use a system approach. So our system is QM plus QW equals 0. So therefore we can set these equal to each other. Q of M equals negative Q of W. So here I've plugged in our values. Mass of the metal is 50. Our C value, or specific heat for our metal, is what we're looking for. We have the 23.5, which is our final temperature, minus the initial temperature of our metal. That all equals the negative mass of the water, which is 100 grams, times our specific heat of the water, which is 4.184, times then the final temperature of the water, 23.5 minus 20. We do the math, we come up with 0.383, which is very close to a value over here on a chart I put on the side here. We're looking at this value here. We look over here at the chart, and it is going to be our value very close to the value for copper. So we're going to say that our metal is copper. So the metal is copper. And that's how you do these problems. Thank you very much.